Top 25 GCP Data Engineer Interview Questions and Answers. In this video, we will explore the top 25 interview questions that aspiring GCP data engineers may encounter. Each question is designed to assess both technical skills and problem-solving abilities pertinent to the Google Cloud Platform. Alongside the questions, we will provide concise answers and explanations. This will help candidates prepare effectively and gain confidence for their upcoming interviews in the field of data engineering on GCP. 1. What are the main differences between Google BigQuery and traditional relational databases? Google BigQuery is a serverless, highly scalable data warehouse designed for analytics, while traditional relational databases are typically self-managed, requiring dedicated infrastructure. BigQuery handles large datasets with ease, utilizing a columnar storage format for efficient querying, whereas traditional databases often rely on row-based storage. Additionally, BigQuery charges based on the amount of data processed during queries, unlike traditional databases that may have fixed costs associated with infrastructure. BigQuery also supports SQL-like queries but is optimized for analytical workloads, making it suitable for large-scale data analysis. 2. How would you optimize BigQuery queries for cost and performance at scale? To optimize BigQuery queries for cost and performance at scale, consider the following strategies. Use partitioning and clustering. Partition tables by date or other relevant keys to reduce the amount of data scanned. Cluster data based on query patterns to improve performance. Select only required columns. Avoid select. Instead, specify only the columns needed to minimize data processing. 3. Use approximate aggregation functions. Functions like approximately _count _distinct can deliver faster results with fewer resources. Materialized views. Create materialized views for frequently run queries to enhance performance and reduce costs. Query caching. Take advantage of BigQuery's caching feature, which can speed up query execution and lower costs for repeated queries. Implementing these strategies can significantly enhance efficiency and reduce expenditures. 3. What strategies would you use for partitioning and clustering tables in BigQuery? Partitioning tables in BigQuery involves dividing data into segments based on a specific column, typically a timestamp. This enhances query performance and reduces costs by scanning only relevant partitions. Choosing an appropriate partitioning strategy, such as daily or monthly partitions, depends on data access patterns. Clustering complements partitioning by organizing data within each partition based on specified columns. This optimizes query performance for common filter conditions. Combining both techniques allows for efficient data retrieval, minimizing the amount of data processed and improving query execution speed. 4. Explain the use case differences between Dataflow and Dataproc for streaming data pipelines. Dataflow is designed for serverless stream processing, offering automatic scaling and dynamic work distribution. It excels in scenarios requiring low-latency processing and event-driven architectures, making it ideal for real-time analytics and ETL tasks. On the other hand, Dataproc is more suited for batch processing and data transformation jobs that can leverage existing Apache Spark and Hadoop ecosystems. It provides more control over cluster configurations, which can be beneficial for complex workloads that require specific tuning. Each service's architecture caters to different streaming requirements, allowing users to choose based on their specific needs. 5. How do you design an efficient ETL pipeline using PUB, SUB, and Dataflow? Designing an efficient ETL pipeline using pub, sub, and Dataflow begins with establishing a clear data flow. Start by utilizing PUB, SUB for real-time data ingestion, allowing for the decoupling of data producers and consumers. Dataflow can process incoming data streams, transforming and enriching the data as needed. Implement windowing and triggering strategies to manage data flow effectively. Use templates for common transformations to streamline development. Optimize performance by leveraging autoscaling features and monitoring metrics to identify bottlenecks. Finally, ensure that the pipeline is resilient by incorporating error handling and retries to manage failures gracefully. 6. Describe your approach to handling schema changes and evolution in BigQuery datasets. Handling schema changes in BigQuery requires a careful approach to minimize disruptions. First, utilize the alter table statement to add new fields, ensuring backward compatibility. Employ a versioning strategy for datasets, allowing for parallel processing of different schema versions. Implement a staging area for data with new schemas, enabling testing before production deployment. Additionally, leverage BigQuery's support for nested and repeated fields to accommodate evolving data structures. Regularly review field usage and clean up legacy fields to maintain an efficient schema. This ensures data integrity and adaptability as business requirements change. 7. How do you monitor and debug jobs running in Dataflow? Monitoring and debugging jobs in Dataflow can be accomplished through several key strategies. First, utilize the Google Cloud Console, which provides a graphical interface to visualize job progress, check for errors, and analyze performance metrics. Enable Stackdriver logging for detailed logs that can highlight issues during job execution. Implement custom logging within your Dataflow job code to capture specific events or errors. Additionally, use the Dataflow Monitoring API to programmatically access job metrics and status. Setting up alerts based on job performance can help proactively identify and resolve issues. 8. Compare the storage options for semi-structured data between Google Cloud Storage and Bigtable. Google Cloud Storage, GCS, excels at handling large amounts of unstructured and semi-structured data, offering a highly scalable and cost-effective solution for storing files in various formats such as JSON, XML, and Parquet. It allows for easy access and retrieval through APIs, making it suitable for big data analytics and machine learning. In contrast, Bigtable is a NoSQL database optimized for real-time analytics on large datasets. It provides low-latency read, write capabilities and is designed for structured semi-structured data, making it ideal for applications that require fast access and high throughput. Choosing between GCS and Bigtable depends on specific use cases and performance requirements. 9. How do you enforce data governance and lineage using GCP tools like Data Catalog? Data governance and lineage can be enforced in GCP using tools like Data Catalog, which provides metadata management capabilities. First, establish a data governance framework that outlines policies and roles. Use Data Catalog to create a centralized repository of metadata, enabling data discovery and understanding. Implement tags and classifications to enforce data policies. Utilize data lineage capabilities to visualize data flow and transformations across pipelines, ensuring compliance with regulations. Regular audits and monitoring can help maintain data integrity and adherence to governance standards. 10. Explain how you'd architect a real-time analytics dashboard using PUB, SUB, and Looker. Building a real-time analytics dashboard with PUB, SUB, and Looker involves several key steps. First, set up a PUB, SUB topic to ingest streaming data from various sources. This data can be processed in real time using Dataflow, transforming it into a suitable format for analysis. Next, store the processed data in BigQuery, enabling efficient querying. In Looker, create a connection to BigQuery and build visualizations based on the real-time data. Utilize Looker's dashboard features to present insights dynamically, ensuring that users can interact with the data and apply filters as needed. 11. What are common pitfalls when exporting BigQuery data to external systems? Exporting BigQuery data to external systems can present several challenges. One major pitfall is not considering data format compatibility, as some systems may not support certain formats like Avro or Parquet. Another issue is inadequate handling of large datasets, which can lead to timeouts or data truncation. Additionally, failing to account for data consistency and integrity during the export process may result in incomplete or inaccurate data. Network latency and bandwidth limitations can also hinder performance, leading to extended export times. Proper planning and testing are essential to mitigate these risks. 12. How do you manage table partition expiration and lifecycle policies in BigQuery? Managing table partition expiration and lifecycle policies in BigQuery involves setting specific expiration times for partitions based on business needs. You can specify partition expiration at the time of table creation or alter an existing table to add expiration. This ensures that older partitions are automatically deleted, helping to manage storage costs. Additionally, using lifecycle policies allows you to automate data retention, enabling you to define rules for archiving or deleting data based on its age or other conditions. Regularly reviewing these settings helps maintain optimal data management practices. 13. Describe your approach to building idempotent pipelines in Dataflow. Building idempotent pipelines in Dataflow involves ensuring that processing can be safely retried without unintended effects. This can be achieved by incorporating unique identifiers for each record and implementing checks to determine if a record has already been processed. Using external storage systems like BigQuery or Cloud Storage, one can store processed record IDs. Incorporating transaction mechanisms can help manage state effectively. Additionally, using Dataflow features like DOFN with appropriate side outputs allows for handling duplicates seamlessly, maintaining data integrity while processing streams. 14. How would you handle late arriving data in PUB, SUB streams? Handling late arriving data in PUB, SUB streams requires implementing strategies like windowing and watermarking. Setting a defined window allows for grouping messages that arrive within a certain timeframe, ensuring that late data can still be processed alongside timely data. Watermarks help identify the delay threshold, enabling the system to manage late data effectively. Additionally, using a dead letter topic for messages that cannot be processed in time ensures no data loss. Implementing retries and deduplication mechanisms can help maintain data integrity when late arriving messages are reprocessed. 15. Explain the use of materialized views in BigQuery for query acceleration. Materialized views in BigQuery serve as pre-computed, stored query results that enhance performance by reducing query execution time. They allow users to run complex aggregations and transformations without recalculating the results each time. When a base table is updated, materialized views automatically refresh, ensuring data accuracy. This feature is particularly beneficial for frequently queried data and can significantly lower costs associated with query execution. By utilizing materialized views, organizations can achieve faster insights, optimize resource usage, and improve user experience by decreasing response times for analytics queries. 16. What are best practices for securing GCP data at rest and in transit? Securing GCP data at rest involves utilizing encryption, IAM roles, and service accounts to manage access controls effectively. Always enable customer-managed encryption keys, CMEK, for critical data, allowing more control over encryption keys. For data in transit, use TLS/SSL to encrypt data moving between services. Regularly audit IAM permissions to ensure only authorized users have access to sensitive data. Implement VPC service controls to create security perimeters around services, preventing data exfiltration. Always keep security patches and configurations up to date to protect against vulnerabilities. 17. How do you design your GCP project structure for multi-team collaboration? To design a GCP project structure for multi-team collaboration, start by organizing projects based on functionality or team ownership. Use folders in the Google Cloud Resource Manager for better management. Implement IAM roles and policies to ensure teams have appropriate access, promoting security and compliance. Establish naming conventions for resources to enhance clarity. Leverage shared VPCs for networking while maintaining separation of resources. Utilize cloud billing for cost tracking across teams, ensuring transparency and accountability. Regularly review and refine the structure based on team feedback and evolving needs. 18. What is the impact of slots and reservations on BigQuery's performance? BigQuery uses slots as units of computational capacity for executing queries. When a reservation is created, slots are allocated from a pool, impacting query performance based on availability. Dedicated reservations can enhance performance by ensuring that queries have consistent access to a fixed number of slots, reducing latency. Conversely, shared slots may lead to contention, affecting query speeds. Adjusting reservations can optimize resource usage for high-demand workloads, ensuring queries run efficiently while managing costs effectively by scaling slot allocation as needed. 19. How do you implement data pipeline orchestration using Cloud Composer? To implement data pipeline orchestration using Cloud Composer, start by defining your workflows using directed acyclic graphs, DAGs, in Python. Each task in the DAG represents a step in your data pipeline, which can include data extraction, transformation, and loading, ETL, processes. Utilize Airflow operators to connect various GCP services, such as BigQuery, Dataflow, and SUB. Schedule your DAGs to run at specified intervals or trigger them based on events. Monitor execution through the Airflow web interface, allowing for easy debugging and management of workflow dependencies. 20. What are the benefits and challenges of using cloud-based data storage solutions? Cloud-based data storage solutions offer numerous benefits, including scalability, flexibility, and cost-effectiveness. Users can easily scale storage up or down based on demand, which reduces waste and optimizes costs. Accessibility from anywhere enhances collaboration among teams. However, challenges exist, such as data security and compliance concerns. Organizations need to ensure that sensitive information is protected against breaches. Additionally, network latency can affect performance, especially in real-time applications. Data transfer costs may also impact budgets, requiring careful planning and management. 21. How would you implement data validation and quality checks in GCP pipelines? Data validation and quality checks in GCP pipelines can be implemented using several strategies. First, define data quality metrics such as completeness, consistency, and accuracy. Use tools like Dataflow to apply transformations and checks during data ingestion. Implement assertions within your pipeline to flag anomalies, such as null values or out-of-range entries. Additionally, leverage BigQuery for post-load validation by running queries that check for expected data distributions. Setting up alerts through cloud monitoring can help identify issues in real time, enabling proactive resolution. 22. How do you perform data migration from on-premises to GCP? Data migration from on-premises to GCP typically involves several steps. First, assess your current data landscape, identifying which datasets are suitable for migration. Choose appropriate tools like Google Cloud Migrate for Compute Engine versus MIS or Google Transfer Service for large-scale data. Create a migration plan that includes data validation and integrity checks. Utilize cloud storage for staging data transfers, taking advantage of parallel uploads for efficiency. Finally, implement a rollback strategy in case of issues post-migration, ensuring minimal disruption to business operations. 23. What are the differences between GCP's regional and multi-regional storage options? GCP's regional storage offers data redundancy within a specific geographic location, ensuring low latency access and high availability for applications needing localized data storage. In contrast, multi-regional storage replicates data across multiple locations, providing greater durability and availability. This is ideal for applications with global access requirements, as it reduces latency for users across different regions. Regional storage is typically more cost-effective for applications with localized access needs, while multi-regional is suited for high availability scenarios and disaster recovery. 24. What tools and strategies do you use for logging and monitoring data engineering workloads? Logging and monitoring data engineering workloads in GCP can be effectively achieved using a combination of tools and strategies. Google Cloud's Operations Suite, formerly Stackdriver, is crucial for real-time monitoring and logging. Implement structured logging in your applications to capture relevant details, which facilitates easier debugging and analysis. Utilize cloud logging for centralized log management and set up alerts based on specific metrics to proactively address issues. Implementing monitoring dashboards in cloud monitoring provides visibility into performance metrics, enabling timely interventions and optimizations. 25. How do you optimize workload cost and resource quotas in GCP environments? Optimizing workload cost and resource quotas in GCP environments involves several strategies. First, monitor resource usage with tools like Stackdriver to identify underutilized resources. Autoscaling can adjust resources dynamically based on demand, preventing over-provisioning. Utilize preemptible VMs for cost savings on batch jobs. Implement quotas to manage resource allocation effectively, ensuring fair usage across teams. Regularly review and adjust instance types and sizes based on performance needs. Leveraging committed use contracts can provide significant discounts for long-term workloads. Finally, optimize data storage and processing methods to minimize costs. In this video, we've explored the top 25 interview questions and answers that every GCP data engineer should be prepared for. Mastering these concepts will boost your confidence and readiness for your upcoming interviews. We hope this content has been informative and helpful in your preparation journey. If you found this video valuable, please give it a thumbs up and consider subscribing for more insights and tips on advancing your career in data engineering. Thank you for watching, and best of luck in your interviews.